Hello, candidates. Ankit Misra this side, and very good evening to everyone. I hope I'm audible to everyone. Hello, Santala. Hello, Vijay, Hima, Neha, Sarath, Tarun, and rest candidate. Guys, I hope I'm audible, right? So let me just share my screen. Can anyone confirm me I'm audible or not? Not. So I have shared my screen. Okay. So class, let me just open the same notebook that we were particularly discussing yesterday. So yesterday we started this project that was completely based upon the RNN, which was like recurrent neural network. And the objective of project was we have to build a model. That model generally takes the movies review, and it is completely based upon the IMDb reviews. And the model has to classify whether the given reviews is a positive review or like a negative review sentiment, right? So let's just give you the quick recap. We have started with this one, right? Let me just connect with the same uh, GPUs, right? Make sure you guys use the same GPUs. You can go to this change runtime and you can change the T4 GPU that has been provided by the Google itself, right? And let me just parallelly share the notebook with all of you, right? Okay. So now the best part is we have already started with the project implementation part, and I think we have completed multiple things, right? So this was all about RNN introduction, where we have to particularly tokenize our data. We can use the Pythonic approach as well, right? And whatever the like individual words that we are getting, we simply represent this as a tokens, right? And if we want to convert that tokens in a set of unique words, so we can use the set concept and all, right? So these were the like previous concept that we have already discussed, right? And when it comes to RNN implementation, so it's like recurrent neural network, and it generally work upon the kind of looping concept, and we have to unfold that technique to understand what exactly this model taking at different time stamp, right? And apart from this RNN, we have another two different modules, models we have, that is LSTM, and followed by the gated recurrent unit, which is GRU, right? Okay, so let's just call all the modules we have started. We have imported all this module, right? And let's just call the data set again. But whenever we are working in this Google Colab, na, so the data set generally downloads on a runtime basis, right? So you have to download that data set again and again, right? Okay, let me just quickly print the xtrain and train and test shape, right? And this code is all about to just call a sample review, right? Now we know that the data set generally stored in a form of vector array, right? But we want to classify the reviews based on the data set that we have, okay? But where is the reviews, right? We are not getting the reviews, right? So you can call the IMDb get word index, and we are just based on that index, we are reversing that word index. Whenever we are getting any sort of numerical value, we have to reiterate the dictionary comprehension, and then we will probably find the word associated with that particular dictionary, right? So we have used this code, and this code is all about to just reverse the word index, where we will simply pass the key value in sort of numeric format, and it will give you the review part in a word format, right? And this is all about the sample review and the decoded reviews as well. Okay, so let's just convert the data set into the training into the numpy array part, right? And we know that the shape could be different, right? So we have used a technique that is called the padding technique. In the padding technique, we have to keep the X train, or like whatever the training data that we are passing to the model, the shape and size of that data should be fixed, right? So we are using the padding technique, and padding technique generally divided into two parts. First is pre technique and second is post technique, right? So right now we are using the pre technique, where we are simply training, or changing our X train data set and X test data set to particularly the pre kind of padding sequence, right? Now if you just check, so you will get the same shape for different any set of random data that you have, right? You can just simply check with this one and with another values as well, right? So this is all about the X data set that we have built, right? Okay, now let's just try to work upon the neural network. Okay, so now we will create a uh, basic simple RNN. So you can just write down this command, and we know that we have to call the model, and inside the model we have to call the sequential method. Inside this sequencer, we have to add our multiple dense layer, right? But before adding that dense layer, we have to convert that word data in a set of tokens. And tokens, we have to convert the tokens in set of embedding techniques, right? And embedding is like it's completely based upon the feature vectorization, right? So in this first sequential layer, what you will do, you will just simply add the directly adding dense layer. You will first add the embedding layer, and just look at this. You are getting the hint right now. Okay. So first we will add the embedding layer, and inside the embedding layer, it will ask you the maximum feature. And let me just show you the maximum feature that we have. It's like maximum features. Uh, we have that maximum feature is 10,000. We have already used this one, and the maximum length as well. Let me just show you the maximum length. Maximum length is like the dataset shape. We have 500, right? So inside this embedding, you have to give the input dimension. So let's just pass the input dimension. Input dimension is equals to whatever the max feature that I have. Okay. And if I just simply take the max feature, then I'll have to decide the output feature, what output dimension I want to get, right? So you can give the output dimension based on like your requirement. So let me just take the output dimension as 28, 32, 56, 64, right? Let me just take output dimension as 128, right? Then you have to give your input length, and we know that the input length of the data set that we have is of 500. So you can just simply pass this as input length is equals to maximum length, and this is your first layer, and first layer of embedding layer, right? And let me just comment out this one. Perfect. Now then we will add another layer. So you can use model dot add, and inside this I'll just simply pass my RNN model, right? So let's just call the RNN model, and inside this RNN model, you have to give the number of neurons, right? It's recommended you can use like any of the neurons value, but it's recommended to just pick the neurons value as the output dimension, right? So I'll just simply copy this 128 and I'll just pass this here. And we know that each neuron has some activation function. So you can just simply call the activation function as the 10h activation function. And this is like your second layer, which is the RNN. Okay. Now I want to add my third layer, that is my dense neural network, because we know that at the end of the RNN, it has to predict the final activation value, like whether the given review is a positive or like a negative one. Okay. So you can just simply pass the dense neural network, and inside dense neural network, you will pick the one neuron, and let's just take the activation function as a sigmoid activation function. Why we are taking the sigmoid? Because this time the output is binary in nature. Okay. That is the reason we are taking sigmoid here. So you can just say this as an output layer, right? Perfect. So let's just run this. Let's just check everything is perfect. Model.add embedding and maximum features perfect. Okay. So we have created one model, right? Now we know that the second step is to compile this model. So you can just simply call model.compile, and you have to decide the optimizer. So let's just simply pass the optimizer is equals to Adam optimizer. Okay. Because the output is like binary in nature. So you will use the binary cross entropy, right? Let's just call the Adam optimizer. Although you are getting hint also, right? So let's just pass the loss as binary, binary, cross binary cross entropy. Perfect. Now the everything remains same. You have to decide the matrix, and inside this matrices you can just simply give your accuracy. So we have compiler model as well. Now the third step is to fit our model, but in the RNN we'll use the build model. Okay, we have that manually technique that first we have to build our model, and how to build that one. So you can just simply call this as model dot build, and whatever the data that you have is like input shape you have to give, and inside the input shape it is like 0 by 500. So you can just simply say 0. Instead of 0 you will write this as none, and none by max length, right? And let's just simply check my model dot summary to just simply call the whatever the parameters that my model is trained on, right? So if you just run this, so these are the parameters, right? Just look at the parameters, like 1 times 100,000, 10,000, like 10, like 30 lakhs of parameter our model are training, right? So this Rest values are coming from the embedding layers, then followed by the 128 neurons, which is a part of simple RNN, and then finally a one dense layer, which is like responsible to give the final output value, like 0 or 1, because it uses the logistic regression backend, right? Sigmoid function, not exactly the logistic regression, but as a sigmoid function. Okay. So what I want, candidate. Okay. In the previous classes, we have seen like our model. If I just simply train my model, right? So before training our model, you have to just simply check the overall, like whatever the summary that you have. You can, okay, it's not like important to use the build here. You can use this build for the like ANN and CNN as well, right? So now we know that what we want to fit our model. But the problem that we faced in the like previous classes, if I model are trained perfectly on 10th epoch, so the rest epoch will be like waste for my model training. Suppose I have given 50th epoch, but my model got accuracy at the just 10th iterations only. So we can use the early stopping technique, and that early stopping is responsible to particularly stop my model training if I got my accuracy or if my got my validation loss up to the given value whatever I am giving, right? So you can use this technique, and that is called the early stopping technique. Okay. And interview generally ask you this question: what is early stopping technique in model training? Early stopping, and we say this as the early stopping callback. Whenever this early stopping callback hit, so model, uh, the training of that model will stop automatically, right? So you have to first call this from TensorFlow. Uh, just simply call this Keras and callbacks, and you will get this early stopping, right? Now you have to create a variable for that. Early early stopping is equals to call this class early stopping, and inside this class, what you want to monitor. So you have to pass this one. I want to monitor my validation loss. Okay. So before stopping my model, now I just check my model what exactly my like model validation loss is. And I'll just keep the patience value as 3, 5, 7, and so on. This will try to check the validation loss for the next fifth iteration. If there is no such changes in that particular validation loss, so model will stop their training. It means that the loss is not optimizing, right? So that is the reason we are calling this early stopping technique. And we have to give the patience value. You can increase the patience value, but it is recommended to use the patience value 3, 5, and 7, 10 as all, right? Not more than this. Perfect. Now, because we are waiting for the 5 patience level, na, so you have to write this argument which is called the restore best weights. What is that? During that particular 5 patience iterations, it will try to restore the best weights. We know that during training process, the last iteration could be like less accurate comparatively to the previous ones as well, right? So this early stopping will try to restore the best weight, right? So you can simply pass this one. And if you just simply run this, now this early stopping will be stored in your RAM memory, right? So you can just simply check. We have created this object which is early stopping object. Now we know that we have to train our model, right? So let's just train model RNN model. Okay. So how to particularly train this one? You will simply call your model.fit, and the rest details, everything same. You can just simply give your x underscore train, comma, followed by y underscore train, right? Then you want to train your model for how many epochs? Epochs. Epochs is equals to 10. It just pass the batch size. Batch size, you have to keep that batch size as like low, so that you can particularly pass the data instead of this batch size, right? Now just look at this. This is the validation data, but we don't want this validation data, right? We are using already the validation concept, right? So you can just simply, instead of this one, validation data, you can just say, let's just simply split my data. So instead of this validation data, what you will do, you will just call your validation split. And this will try to, let me just write this one. I'm not getting the hint. Validation split. Okay. And you have to give the percentage. 20% data I will use for my validation. Okay. And whenever I am training my data or my model, and if I get the fixed value of accuracy, and if my loss is not decreasing, so I will call my early stopping, and I'll call my callback, that is called early stopping. So you can just simply call your callbacks, and you can just write this one. What you want to callbacks? BACKS. I want to callbacks my early stopping, and just keep the patience value at 5, and just try to look at the 5 iterations. If the loss is not decreasing, so just try to stop the model training and get store the or restore the best weights, right? So if you just run this, make sure you are using this T4 GPUs, right? Okay, well, the data training is very less right now comparatively to the CNN part that we are performing. So you can simply run this one, right? Let me just check everything looks good. X-train, Y-train, epochs, best size, validation, so on and so on. Okay, let's just try to increase the epochs value, right? So that you can understand the how exactly the, okay, could not interpret binary. Okay, my mistake, candidate. So once you give this loss, so you have to give the binary cross entropy like this. Okay. So let's just again pass the model summary, and let's just simply run this callback again, and let's just call this model.fit. Okay. Now just wait for this. Okay. So we are training our model, and the first loss we are getting is very less itself. Although accuracy is good, right? 53% of accuracy. So this will try to run. And I don't know where this model will be like stopped, because I am using the early stopping technique. Whenever this early stopping finds the best value with the patience value of 5, so it will just try to stop the model training, right? So already we have given the 20 epochs, but let's just wait for this to complete, right? And if you are not particularly using the T4 GPU, so it will take so much of time, right? So I hope everyone is getting my point, candidate. Is there any doubt? Just let me know. Tarun, Sarath, and other candidates, guys. If you have any doubts, you can let me know right now. Okay, so we'll just wait for this to complete, and just look at this. During first iteration, our loss was 68, 0.68, right? And the accuracy was like somewhere 0.54. Now just look at this. During 3 epochs, third iteration of this epoch, we are getting the accuracy some sort of 0.74, and the loss is somewhat around 0.52. Okay, and just wait for this model to like trigger this callback, right? Okay, so we'll just wait for this to execute. Once our model will train perfectly, it will call the callbacks, and that is early stopping, and then we will save our final model. Okay, once we save our final model, so then we can finally create or deploy a web app, and I hope everyone is already aware with that web app, right? We will use the Streamlit technique, and with the help of that Streamlit, we will try to particularly create a web-based application for our client. And let me just show you that one thing. We have created, I think, more than 2 or 3 projects, right? First was based on that ML one. Second was completely based on the ANN part, right? Third was completely based upon the CNN part as well, right? So what you can do, candidate, you can have this Streamlit ID, right? And on this particular Streamlit account now, I have posted like multiple projects as well, and you can just take a reference, right? So I'm completing this project right now, but you will just go to this my Streamlit repo, and you will click on that particular one, right? AI chatbot, and this AI chatbot, if you just click on this now, this will open the web app, right? If someone is not using this web app, so this Streamlit will try to hibernate this web app, so that it can like save their server side and the usages and all, right? So let's just wait for this to run. And meanwhile, let's just check our model is training, right? So just look at this, the accuracy of 0.54 to 0.84, right? And still we haven't call back the early stopping, right? Okay. So error running app, if you need something, okay, let's just use another one. I have this one also. Okay. So you can just call this like URL Streamlit, and you can fork any of the GitHub repo, right? You can take a reference of this project. You can create this project on your own. I'll give you 2 or 3 projects link over the same GitHub, right? Whatever the GitHub ID I have shared. You can just take a reference of that GitHub notebook and you can just create your own projects. Okay. And just understand one thing, candidate. In this particular AI ML field, now we have multiple things to learn, right? And it's requested to all of you to particularly spend some times to learn more and more, right? Because the market is changing very drastically on day-to-day basis. Okay. We are getting multiple AI agents on day-to-day discovery, right? The cloud has launched their multiple AI models. Chat GPT are working rigorously on that model training, right? Perplexity has launched their new product, which is computer kind of something, right? Where you can like talk with your computer, or you can just give a task to your computer. Hey, I want to train my model, right? So you can just do a verbal communication, and that model will eventually pick that data. It will do all the pre-processing, whatever the one hot encoding, embedding techniques, whatever required, right? And then based on that, it will create a model, even deployed the model as well, right? So we are heading towards that era, right? So we have multiple things to cover up, we have multiple things to learn. So I just request you, all of you, to particularly take a reference of everything. Don't try to memorize everything, right? Because you can just have a like reference of each and everything whatever you are learning, right? If you try to memorize each and everything na, so you will probably fed up, right? Because we have multiple things to execute, multiple things to perform, right? And now look at the complexity of the modules, right? How you can like how one can say I can simply memorize all the modules, right? You can just particularly take a reference. Okay, these are the modules, and each module is responsible for this one, so that you can understand the model deployment, building part, execution part, training part, testing part, and so on and so on. Okay, now just look at this. We have given the 20th epochs, na, but the model triggered that callbacks at the 11th iteration only. Okay, because this was due to the no changes in their validation loss. Okay, and it has tried the patience of 5 iterations, but it somewhat check. Okay, the accuracy or like the loss is not decreasing, accuracy is not increasing. So let's just trigger the callback. Okay, now we are closely to 90% of our accurate model, right? And we are getting the accurate model right now. Okay, so what you can do, you can just simply save this model. How to save this model? Okay, I have already told you one thing. If you are working on ML project, you can save your model using the Pickle module, right? But if you're working on the deep learning concept now, either you have to save your model on HD5 format. Let me just show you this again. Pickle versus .hd5 format versus Keras format. We have three different formats, right? To save what? To save models. Okay. If you want to save your ML models, you can use Pickle concept. Okay. And just look at the answer, right? When saving machine learning model, we will simply use the Pickle concept, right? If you want to save one hot encoding, if you want to save standard scaling, if you want to save any sort of Python object, so you can use the Pickle. Okay. Keras is recommended for any sort of complex deep learning models. Okay. And this is the updated version of .sd5 format. Okay. So in the last class CNN model, we have used this model.h5 format. In the previous ML class, we have used this Pickle1 format. Okay. Now this time we will use this Keras format so that you can simply understand, okay, we can use any sort of technique on any sort of model saving. But when it comes to deep learning, we have to use H5 format, or like we say this as SD5 format, and second one is .keras format. You can take a reference of this one, right? And let's just move to save this model, right? So you can write this one, save model file, and let's just write this as model.save. Either you can give the SD5 format or like .h5 format, or we can simply give as like this simple RNN, and this RNN is for what? IMDb, and let's just write this as a Keras. Okay, what is the use of this Keras, right? Whenever you are saving any model with the Keras, na, it saves the overall weight training part, right? It also saves the overall like history, whatever the history log, whatever the details that you have, right? It the graphs architecture, it try to save everything. Okay, that is the reason it is recommended. Okay, so, okay, now one more thing, candidate, whenever you are training your model, I'll just suggest you to store that training part in some sort of variable like history. So that if someone asks you to particularly, okay, show me the overall training path, right? How my validation loss of like behaving during that training iteration, how my accuracy are particularly comparatively to the validation accuracy. If you want to show, we have already used this one in the previous classes, right? But it is recommended to use or to store that fit part in a history kind of thing, so that you can call back your histories and you can trace all the training methods or like the path that the model has decided to form, right? So but right now we have already trained that model, so let's just skip this one. Okay, okay, so let's just save this model. Now we have saved this model, you can just simply look at this. Okay, this is the model. Okay, now we know that after saving this model, what we want, carry it. We want to create a model or like the app.py where we can simply give this Keras model or some sort of any IMDb data. Okay. And based on that IMDb data, it will try to do what? It will try to particularly perform some sort of prediction part, and this model particularly give you whether the given like review is a positive or like a negative review. Perfect. So let's just do one thing. I'll just simply use my local host Jupyter notebook, because I know that the Google Colab does not give you the like particularly approach for to build Streamlit web app module. Although we can build it, right? You can just simply right click on this, click on new file. You can just simply write app.py, right? But the problem is we cannot test that on a runtime basis. If you want to do this, you have to use the local host kind of thing, right? So let's just click on this new file. Why I'm not getting the new file right now? Let's just wait for this to save. Okay. Parallelly, I have used this one. I'll again right click on this. I'll click on new file. Let's just wait for this to execute. I'm not getting the option, right? Why it's not working? Let's just again click on this. Right click on this new file. Okay. So this is some sort of issue, right? So let's just wait for this to execute, right? There might be something issue. Okay. Now just look at this. Let me just check. Is it something like a network issue from my side? Guys, am I audible now? Can anyone confirm me? Your system load is heavy. Can anyone confirm me? Am I audible or not? Tarun, Sarath, Vijay, Hemant, Neha, Vaishnavi. Okay, good. Perfect. Because I was not able to create file now. So it can be due to the network issue, right? So let me just delete all this file. Perfect. Now I'll just simply click on this, go to this rename file, and what I want candidate, you can just simply write this as app.py. Okay. Now parallelly, let me just open my Jupyter notebook as well. I'll just go to my new folder and RNN IMDb. I'll create a folder RNN IMDb, and inside this RNN IMDb, first, I'll download my model. Okay. So let me just download my model. My model is simple RNN imdb.keras. Okay. Now this time the size of this model is less than 25 MB. So I can directly upload this model over my GitHub repo, right? In the CNN model, we have to upload that model over the Google Drive link, right? I hope everyone is aware with that, right? So let me just go to this. I'll simply upload my model here. Where is my model? Just go to this download. You can click on simple RNN imdb.keras. I'll upload this one. I'll just go to this new and I'll click on this new file, and let's just start with app.py, right? App.py. Okay. Now the best part of this app.py, now I can simply run my Streamlit web app here. Okay. And it will allow me to check my web application on a runtime basis. And then that is the use of that, right? So let's just quickly call all my modules. I'll just simply go to my Jupyter notebook. Whatever the modules that I have, let me just simply copy and paste, import NumPy, import TensorFlow. Let me just copy this one. I'll paste here. Okay. I'll paste IMDb as well. Where is IMDb? Yes, this one. Perfect. Let me copy this one. IMDb. Okay. Now I want to load my model as well and the padding sequence as well. So for the padding sequence, I need to use this module. Let's just use this one. Okay. Now we have saved that model, right? So how to load that model inside this app.py? So for that, you can just simply write this as from tensorflow.keras. Okay. From tensorflow.keras, you can call the models, and inside this model, you'll get this option which is called load underscore model. Perfect, candidate. Okay. Now we know that because we have to perform the padding sequence and some sort of like reverse indexing technique, So we have to call that same one which we have used in this notebook, right? So I'll call this one word index is equals to IMDb dot get word index. So you can just say let call word index. Okay, and you can just paste this here. And I want to create a dictionary for that word index. So let's just call this reverse word index as well, because user will not give you data in a sort of numerical input, right? User will give you the data in sort of reviews part. Okay, and we want to map that reviews in sort of numerical vectors. So for that we need this reverse word index. Okay, so let's just call our model. How to call that model? We have this load model method, and this load model method allows us to load that model. And what is the name of that model? The name of model is simple RNN imdb.keras. So let's just go to my final this Keras model. I'll copy this one. I'll simply click on this and paste this one. Perfect. So this is my mode, like overall model. Okay. Now just assume one thing, candidate. Okay, so let's just do one thing. Let's just first write st.title so that you can understand we are working st.title. Okay, IMDb, movies, reviews, sentiment, analysis. Okay, so let me just call Streamlit as well. Streamlit as st. Okay, now I'll go to this one. I'll click on my new. I'll click on my terminal. Okay, and inside this terminal, first of all, I have to go to that particular root path. Okay, so I'll just first wait for this. I'll change my drive, and inside this one I'll use RNN path. Okay, I'll hit the tab button, and inside this folder I'll first call my Streamlit run, and the name of that file is app.py. Okay, once you run this, you'll get a localhost window, and there you can create your web app, right? So import TensorFlow as TF. Import TensorFlow as TF. Okay. Now this time I can run my, let me just copy this one because right now I'm not connected with my mobile internet. So this time I can simply pip install the modules, right? So let's just call my pip install TensorFlow. Okay. So you can just copy this code, pip install TensorFlow. Where is pip install TensorFlow? You can just copy this reference. Okay, and now just go to this terminal. You can just simply write this one, pip install TensorFlow. The module is, I think, of 300 plus of MB, so it will take some time. It will download all the modules. Okay, and yes, it's downloading some sort of modules. And once it is done, then we will call our like app.py again, and then we will build our model, right? Okay, because I directly use the GitHub Copilot and all, where I can simply dump all my app.py, and where I no need to install all the modules, right? Because it is directly connected with the Streamlit web app. So whatever the modules that I am using, it directly downloaded by the Streamlit itself, right? I just simply give the requirements.txt file, right? Because I am just giving you the concept or like the approach how to particularly do this in a localhost environment, right? So for that you have to do everything, right? And you still require a requirement.txt. Okay, so let's just wait for this to execute, and then we will start with the. Okay, now parallelly, let's just do one thing. Once we load this model now, just assume one thing, right? The user will give the textual data. Okay, now what you have to do, you have to decode that textual data in a form of like decoded review so that you can particularly show that review, right? And you have to pre-process that text. Perfect. So let's just write a function, and the name of that function is whatever we are using here na, whatever the technique that we are using. Where is the decoded review technique? This one, right? So for that we will write a function. So decoded review, decode review, and this decode review will simply take what? It simply take encoded review. If you just understand this thing now, so this concept is very similar to the transformer architecture where you have to encode your embeddings, and then you have to follow some sort of self-attention mechanism, and then you have to decode that embeddings as well, right? So let's just simply Go to this one. I'll simply copy my this technique. This is like for the decoded technique. I'll just copy this one. Okay, I think there is some sort of like system issue from my side, guys. Just give me a second, right? The system is not responding. Just give me a second. Hmm. Can anyone confirm me I'm audible or not? See, that is the reason I usually don't use the local host, right? Because multiple things are running on the background of this laptop, right? And that is the reason, right? Okay, so just give me a second. Okay. Is there any issue with the screen sharing? I hope everyone is getting my screen right. Can you please confirm me this? Okay, perfect. So let's just check this one. See, you can just check the tabs, right? There are multiple things are running right now in the at the back end. So, okay, where's the Jupyter notebook? It's downloading, right? Okay, so let's just go to my this decoded review. I'll copy this one decoded review and let's just paste it, right? So what this will function perform, it can simply take the encoded review and this will give you the decoded review, right? Okay. Now, whatever the review that we are getting, we want to pre-process that text. Okay. Now just look at this. We are not simply like giving the data. We have to pass the data using the padding sequence. Na? So again, we have to use this technique, right? So let's just again create a function for that, right? If we are doing this in a notebook, so you can simply run your code. But if you are doing this in app.py, it's recommended to use the functional approach, right? So let's just create a function that is called preprocess text. And what it will do, it can simply take the text as an input, and once it take text as an input, then you will first find the words of that particular the text that you have. Okay, now the text can contain meta characters as well, so it can contain duplicate characters as well. So you will just simply convert this to lower text, and we are already aware with that we can simply split the text using the space part, right? Okay, so this is the words in a form of textual data. Now we have to convert that word in a form of encoded part, or like the numerical part. Okay. So let's just write this as encoded, encoded review. Encoded review is equals to, I'll use my list comprehension and I'll just simply iterate each word over this word. So I'll just write for word in words. For word in words, what I'll do, I'll just simply call my word index. Where is my word index? This word index. And I know that in this word index, I have the like word and then followed by their numerical value. Okay. So I'll just simply go to my word index. Okay. I'll just call my word index. Okay. Let's just call word index. And this is a dictionary. So inside this dictionary, if I simply pass my word here, this will give me the overall numerical value. Okay, there might be chances I'll not get any of the matching words. So what I'll do, I'll simply give any of the random value 1 2 3 and 4, right? Okay, because the previously we were starting with the -3 approach. So let's just increase the 3 approach, because the initial 3 word character are for something else, right? Okay, so we are giving this word index dot get word, and dot get is a dictionary method. Then we will get the encoded review and it is in a numerical form. Okay, so let's just write this as a numerical form. Once we get this encoded review, okay, so what we want to convert that in a sort of padding technique, right? So let's just first write this in a numerical array, okay? And let's just give the padding to my numerical array. So you can just simply use this as padded review. And how to give the padding? So either you can use the function for that, or you can simply use this technique, which is sequence dot pad sequence, and you have to give that one, okay? So let's just copy this one. And we have this module that is called sequence. Inside this sequence, we have to pass the pad sequence, but this time we don't want to pass the extrain. We have the encoded review. So we have to pass this encoded review in a sort of array, and whatever the maximum length, so you have to give the maximum length. And let's just simply give the maximum length as I think we were using this as a 500 na. So let's just call this as maximum length as 500. Now this will try to call that value here and we will get the maximum length as 500, or even you can write it like manually as well. Perfect. Okay. Now once we get this padded review na, so this function will try to return this padded review. Once we get this padded review, now I can simply feed this padded review into my model. Perfect. So let's just simply start with the st.title and Streamlit run script is a Streamlit is still running. Let's just check this to complete. Okay, it's perfectly working. Let's just simply clear the screen. I'll simply hit my like Streamlit run app.py. Now this time it should work, right? Okay, let's just wait for this to execute. So I think we will get the title right now, okay? Because we have simply imported all the modules related to TensorFlow, right? So it should work. So let's just wait for this to execute. Then whatever the changes that we are applying over the app.py, na, yes, perfect. We are getting this one, right? IMDb movies, review, sentiment, analysis, right? So now whatever the changes that you are performing here, okay? So you can simply change, like it can be directly reflected here. You can just check, right? Instead of reviews, I'm using the review word. So here I'll simply get the updated value, right? Perfect. Okay. Now inside this st.title, see, this is for the local host at 8501 port, right? So now you can simply give multiple things, right? So IMDb movie review sentiment analysis. And now let's just write something about this st dot write what user can do. So enter a movie review to predict, or instead of predict, let's just write this as to classify its it as positive or a negative or negative, right? So whether the given review is a positive or like a negative review, okay? Now if you just simply hit Control S now, so you will get the updated value here, right? Let's just refresh this one. We will get updated value, right? Yes. Enter a movie to classify it's a positive or like a negative. Okay. Now at this st.write, I'll just take the input from my user. Okay. So let's just simply give this st dot. We have this input method that is called text area. Why I'm not calling the input? We have the input method as well, but this text area allows us to paste good amount of data, right? That is the reason we are calling this. So let's just write this as movie review. Okay. Once you call this, you will get the like text box, something like this here. Movie review like this. Perfect. Let's just save this one first. You will get the movie review like this. Okay. Perfect. Now what you want, if the user gives this like text area, whatever the text message in this, so you can simply store this inside the user input. Okay. Now you just create a button and we have that button which is called st dot button, and inside this button you can just simply hit this classify, or let's just use the magnifying something like this magnifying object. We have this like emoji na magnifier emoji. I'm not getting the magnifier emoji. Let's just go to Google. I'll simply write this as magnifier emoji. Yes, I'll copy this one. I'll paste this classify here like this. Perfect. Got it. Now once I save this, so I'll get something like this. You can just simply check this one. So what is the issue with this one? Okay. So we are writing this if now. So you can just simply complete this statement. If the user has given the input, right? If user has given the input, right, whatever the input that you have, so user can click on this st dot button. Okay. So this st dot button, what it will try to do? It will first try to pre-process your data. So where your data is at like a user input. So you can just simply call this function. What is this function? This is like pre-processed text. So let's just call this function, and inside this function, what you want to pass? You want to pass your user input. Okay. And when you pass this user input now, okay, just give me a second. Yes. When you pass this user input, So you will get some sort of like processed input. So you can just simply write this as a process input data. And now you can call your model to predict that particular answer, right? So let's just simply call my model. My model is stored with the name of model. Inside this model, I'll use this predict method. And this predict method generally takes this like process input. Okay. And whatever the output that we are getting, and let me just write this inside this prediction variable. Okay. And this prediction variable is like in a set of array. So you can just simply call this array, like you can just slice the value here directly. Okay, prediction. And this is like in a 2D array. So let's just call this 2 times, right? So you can just simply call the sentiment. And how to call the sentiment? You can just run your like if else one liner if else. So it's like if my prediction value is greater than, because the output neuron that we are using is the sigmoid activation function, so it will give you the value within range of 0 to 1. Okay, so you are just saying if the prediction value is greater than 0.5. So what I want to classify my review as a positive positive review. I want to classify my review as a positive, or otherwise I'll classify this as a negative one, right? And whatever the answer that I am getting candidate, I'll just simply storing that inside the sentiment. Okay, now I just want it I just want some time to predict. Okay, so let's just write something like this with st.spinner. We have this method that is called st.spinner with st.spinner. And let's just take a documentation help for this. st.spinner. This allows you some thinking time, right? And you have to write something like this, wait for it, and this will give you the value, right? Once you can like run your the time iteration as well. So let me just copy and paste this one with st.spinner, uh, classifying or predicting whatever, you can just write for this, wait for it. Okay, and you can call your time. So let's just import the time module as well, import time. If the user will click on this st dot button na, so this will like classify all the value. Okay, so let's just do one thing na, because this process will take time, right? So when this click na, so it should particularly wait for this to execute, right? So let's just give the 3 second or like 2 second. 3 second is enough, right? And after this 3 second, what I want to predict my sentiment and with the score, right? So let's just write this as st dot success. And inside this xt dot success, you can just simply write your value, and success is for like the green output. You can just simply say this as the sentiment. The sentiment of review is like, you can just simply call your sentiment here value. You're getting the sentiment value from here, right? Okay. And you can just give the information as well, st dot info. Again, let's just call the f string and the prediction score. And the prediction or like the confidence value, sometimes we also say this as a confidence value. And the prediction score is something like this prediction. Okay, you can call the prediction directly. Perfect, this is the prediction value that we are getting. If you want to multiply it with like 100, so you will get the some sort of percentage values as well, right? So let's just run for this to execute. Okay, so if the user will not click on this button na, so what we want to process, right? So we can just simply say please enter a movie review. So if user will not click on this button, so I can just simply say this inside this else st dot warning. Let's just use the warning, right? Please enter a movie. Please enter a movie review. Okay, now let's just save this, and I'll go to this one. I'll simply refresh this one. So whatever the execution that we have performed, okay. Is there any issue expected else? Okay, my mistake. So just go to this. Whenever you are using one liner if else na, so you have to write something like this. If the prediction value is something like, so it will execute this one. Otherwise else this one, right? Else part was missed. So just refresh this again. Perfect. So I think we will give yes, we are getting the movie review area as well, and user can click on this classify and please enter the movie review. Okay. Now let's just simply go to Google and just Give one example of like Iron Man IMDb movie review. Okay. So it will give me one example of IMDb movie. Okay, it looks fabulous and something like this. So I'll just simply copy this one, and I just need to check the overall sentiment of this one. So I can simply copy and paste it here. I'll click on this classify. This will take some time. Okay, wait for it. See, are you getting the answer now? Wait for it. This is for the like spinner, that the technique that we were using. And just look at the result candidate, right? We are getting the positive result. Okay. Now just try to read this one. Okay. Inside this st.text area, na, this will give you the text to read out, right? It looks fabulous. The whole film is like very slickly made with top-notch special effects and so on and so on. And you're getting the positive, right? Okay. Can we just try something like this? Okay. Instead of this Iron Man, na, let's just try with some like book review. Well, we haven't trained this model over my book, but we generally consider this as a transfer learning where we have trained our model on some other data set, but we are using this for somewhat similar data set, right? So instead of this now, let's just write give one example of book review of Ankur Wariko, right? I'll just simply use this Ankur Wariko book, and this will give you me one overview. Okay, where's the review, right? Just give me a review now. This is the okay. Okay, let's just this is the final, right? Okay, give one example of a book review. These are the overviews, right? Over just let me just write. I'm not getting the example, right? See, these are the overall like something key takeaways. Okay. Okay, so there is no example that I'm getting over this book, right? So uh, what to do now? Again, give one example of book review of Ankur Wariko. Do epic shit. Okay. If I'll not get the answer, na, so I'll use Chat GPT right now. Go to this Chat GPT because it should give me the like one review. Give one example of book review. Okay. So let's just wait for this to execute. Okay. The example is very big, right? Okay. See, I want a user review. I think I have given a wrong prompt. Na? That is the reason I'm not getting the exact answer, right? Okay, a review by a reader. Okay, so let's just give short, right? Give short user review. Okay, well, my model is not trained on that, right? So let's just copy this one, and I'll just copy this review. I'll go to my model. I'll paste my review here. I'll click on the classify, and now just wait for this to execute. Okay. Okay, see, look at this, right? We are getting the positive, right? Okay. Can I just say, okay, for some experimentation purpose, okay, for some stuff, I need one one negative review, right? I need one negative review, okay? So let's just check this one, whether this is particularly classifying or not, right? Well, the model is trained on IMDb, right? So just for experimentation purpose, we are just checking whether this model is working or not. Right? Now just look at this candidate. I think like everyone is like amazed with that, the result that we are getting. Yes, you know, Tarun, Sarath, Vijay. Well, we have trained on. Sir, can we use also? Yeah, yeah, perfect, right? Yeah, thanks for this to point out, right, Harsha? We can use the JobLib as well, right? JobLib is also very popular, right? Somewhat I forget the name of this, but the JobLib is also very popular. You can just use the JobLib to dump your model as well, right? The way we use Pickle, na, so we can use the JobLib, but again, JobLib and Pickle are recommended for the machine learning aspect, right? But when you are using the deep learning stuff, na, so you have to deploy, sorry, you have to like save your model using the SD5 format or like the Keras format. Perfect. Now the best part is we have trained our model on IMDb reviews, right? But we are checking that model with some sort of sentiment analysis for our books review, right? This is the power of like this language technique, okay? And that makes that language as an intelligent part one, right? Perfect. So now you can just simply do some like stuff with that one. So let me just simply copy this one. Well, we have created this module. So you can do this stuff, right? I'll just simply go to GPT, and because I want some sort of like UI and UX part for this. So you can just do this. Well, it is not recommended to learn all this stuff. You can just hit and try, right? And this concept is called the vibe coding, right? So below given, let me just simply write this as below given is a complete Streamlit app.py. I want you to make this with like good UI and UX features for users, and give some markdown on bottom. Okay. Also use sidebar properties of Streamlit to show something. Okay. Okay. So you can just like skip the spellings, right? I am just simply writing the one. Okay. So these are my app.py. Okay, whatever the models that we are loading. Okay, the first thing that we are getting is the page configuration. Okay, it is recommended to use this one, right? The second thing is very important, that is called st.cache resource. Whenever we are calling our model, the model size can be huge. It's like 2 GB, 5 GB, 50 GB. So if the user will click on classify, the model will try to reload again and again. So what we are doing, candidate, we are just simply storing that model inside a cache or like online memory databases. It's like a cache memory databases, and the rest everything is same, right? The process part, the predict sentiment part as well. Okay, now just look at this. We are not using the hard coded, and it is recommended to use the prediction function. Okay, and these are the sidebar marked on the threshold value that we are getting st dot slider. Okay, the minimum value, maximum value, and these are value for what? These are value for the sentiment, right? Now you can just pass all the values. You can just simply use the like overall reviews. You can just paste overall reviews here. Okay, it has used multiple things, right? Column 1 and column 2, st.text area, the column 2, it will give you the positive examples as well and the negative examples as well. And if the user click on this sentiment button, so this will give you the progress bar, and with the progress bar, this will try to predict the values as well. Okay, because I have used the prompt like UI and UX, that is the reason I'm getting like multiple result here. Okay, so let's just copy this one. You can take a reference of this. I'll just simply comment out all the stuff, right? And I'll use this one. So that this original one will also be part of my code, and you can just take a reference of this one also. Let's just copy this. I'll just quickly refresh this one. Now what you have to do, candidate, now just look at this. Okay, just look at the like changes that the GPT has performed, right? You can just select the sentiment threshold. What is that sentiment threshold? We are using the sentiment threshold at 0.5. If the value is like greater than 0.5, so it is like positive, and like the negative one. Okay, so based on this, now you can simply paste your values. You can just simply copy the one example movie review, like negative review. Let's just try check like this as a negative one, and this will give me some sort of negative review, and I'll just simply copy this one. And now user can simply you can like create your fast API where you can write some like get and post request, and where user can simply give the message area, like the messages or at that particular level, and it will predict the value, right? So just click on this. Now this is the progress bar, right? And the sentiment is negative, and the confidence score is 0.47, right? So look at the overall like the quality of this project. Now I'll give you one homework what you have to do, candidate. Okay, well, it hardly take me a minute, right? So let's just do this also. We know that we have a requirement of the file that is called requirements.txt. Okay, so just simply I'll write this one. You can like skip the spellings. These are the things that we generally require: TensorFlow, like Streamlit and the NumPy. Okay, and see, if you are working on the specific version controller, so you can like this, you can write like this, right? So let's just skip the version control part, but it is recommended when you are working on the Docker container, and if you are working for the production deployment, so it is important to use the version part as well, right? So what I'll do, I'll just simply go to my GitHub, right? Because I have simply deployed all the modules. I'll just quickly deploy it over the Streamlit, right? So that you can also check this. I'll create a new repository. Okay. And it hardly take 5 minutes, right? So I'll just create a new repository. And what is that? IMDb sentiment analysis. Okay. IMDb sentiment analysis. Let's just on this README file. Okay. You can take a GPT to create this README file as well, right? I'll just go to this add file. I'll click on this create new file. And inside this new file, I'll paste all the requirement.txt. And here you can just simply write requirements. This time you cannot write the like wrong spelling. So requirement.txt, let's just save this file. Okay, not here. You have to save this file. You have to do the commit changes, right? So this is requirement.txt file, right? Now, the second thing that we want is my model, okay? So I have already my model. So let's just upload my model because the size is less than 25 MB. So I can simply upload my model, right? So my model is somewhat here. Okay. Now just quickly call the Streamlit. Okay. And I'll create a new app. Okay. So the third thing I also need is like app.py. Okay, so let's just save this app.py. I'll just go to this, click on this download. Okay, yeah, instead of this now, let's just do one thing. I'll copy this one. I'll go to my repo, click on this add file, click on this create file, right? You can create file directly here. You can paste your all the codes and app.py, right? And let's just do the commit changes. Okay. And parallelly, what I want, I'll just go to GPT and I'll just say, okay, give me .md is like the markdown file, .md file, okay, for markdown of my project. Okay, this helps us to like for new user to particularly understand what exactly this project is. Okay, and whenever you are working on any of the project now, you can take a reference of any of the like GPTs or like Gemini, and you have to do that stuff, right? Because we don't want to waste the time on all these things, right? If you have time, you can do some research. If you are like at your learning stage in the industry, we are using multiple like LLMs and GP integrations so that we can particularly give the quality result on a like very short time, right? So it is recommended to use that all the vibe coding aspects and all, right? So now let's just call this my IMDb project, IMDb sentiment analysis. And the main branches, the file name is app.py. And let's just quickly rename this IMDb sentiment analysis. Okay, the spelling is wrong. So let's just correct this. Senty sentiment analysis. The domain is already taken by Ankit. You can just simply write this one. Okay, so let's just quickly check everything looks perfect. Okay, now just go to this read.md file. Okay, you have this GPT data now. Just simply copy this dot markdown file. Go to this, edit this file. Which file? .md file, right? And you can simply paste your all markdown like code here, right? Now just look at this. Whenever a new user click on this now, so this will give you something like this. Okay, this is the overall .md or like the introductory part of that your project. Okay, you can write your name as well, right? Now I'll just simply click on my deploy because everything is already ready. Okay, so if I just click on my deploy, so this will take some time. It will try to like install all the modules and the libraries. And once it is done, so parallelly, you can open this URL and now you can build your project as well. Perfect. I think it's done, right? So candidate, let's just wait for this to execute. And one more thing, I'll just quickly suggest one more thing because there are multiple things to learn, right? So this is from my side, and I'm just finalizing your overall curriculum right now. Okay, so this will be the last class, right? And you can just take a reference. If you want to learn more, you can connect. Okay, you can have a words with your like the counselor or like the faculty coordinators. Okay, so this is from my side of overall machine learning to like deep learning and overall AI stuff, right? Where there are multiple things to still learn right now. So you can just have a reference, you can practice it multiple times. And I'll just simply suggest one thing, try to create more projects and look for more interviews, right? Once you ready with your interviews or like the basic stuff, then you can create multiple projects on your own as well, right? So let's just now user, you can use this URL as well, right? So you can just simply go to Google, you can copy any of the positive or like the negative review, you can paste your positive negative review here. You can click on analyze the statement. This will take some time and the statement is negative. In the same way, you can use the positive one. So let's just go to Google and let's just call the positive one. Okay. And this is the final that we are using. So absolutely amazing movie. Okay. Let's just simply call with this very basic one, like amazing movie. Okay, let's just call this as amazing movie instead of like giving so much of like text for the sentiment. Na, let's just simply call this as amazing movie. And then look at this, right? We are getting the negative result, but the confidence is very low. Why we are getting the negative result? Because the sentiment is very, like the textual data is very low. Okay, and that is the loophole for this RNN, and that's where the new model came into the market, which is called the transformer architecture, which is exactly the part of large language model and the generative AI stuff, right? So guys, I'll suggest you to read more about this, learn more about this, and I have already shared you this URL with you so that you can practice it along. Okay, now you can do one more thing. I'll just go to my Streamlit web app. Okay, and you can take a reference of the applications or like the project that I have shared, and even you can go and Google the multiple project that already hosted on the Streamlit. You can take a reference. Okay, and when you got any of the projects, right, so what you can do, you will get definitely this option. And what exactly this option? This option is somewhat like this. Okay, this is called, you can fork your repository, right? Let me just paste the URL again. Where is that URL? I need to copy this again, right? So I'll just go to this. Let me just directly click it here, right? So this is the URL, and once you get any URL from any of the user, like, so you can fork their repository. You can call all the codes and you can take a reference of that code. You will get the option from here, right? Once you click on this, this will redirect you to the GitHub link, right? And there you can take a reference of all the codes like requirement.txt, simple RNN model, and the app.py, right? So class, this is from my side, and we have learned multiple things. And now you can simply understand all the things. You can create your multiple projects from your side. Okay, and still there are multiple things to learn. I'll just simply wish you all the best so that you can learn more. And if you have any doubts, right, we have almost spent more than 20 plus of hours of learning, right? So you guys, if you want to say like anything, you can just let me know. You can connect me over the LinkedIn as well, right? Or you can connect your like faculty coordinator or like the management to learn more about the things and all, right? So this is from my side, and this will be, and this is the last class. So if anyone wants to say something or any sort of doubts and questions, they can let me know. Or shall we close this one? Tarun, Sarath, and the rest candidate, Harsha. Okay. So Hemant, Neha, Vaishnavi, Bhumika, I think it's good to go, right? So let's just close the recording. And again, I'll wish you all the best. Just learn more, enjoy more, and just create some more stuff and projects and just connect. Okay.